So after the search problem, we discussed about the sequential search as well as the binary search. Let's take a look of the other problem. And in this problem, it's a little bit more complicated, and we will try to see 3 different kinds of programs to solve the problem. At the same time, we can compare their big O analysis. So the next problem is what we call the maximum contiguous subsequence. So let's try to understand what is this problem first. In this problem, given some positive values and some negative values, and we try to put them in an array, and what we want to do is try to find the maximum, and the keyword here is the contiguous value of sum of AK where K equals to I through J. So what that's trying to say is that in that sequence, we need to try to find a sequence that are connected to each other. They are contiguous numbers, and we want to find among all of those values what is the maximum sum that we can get. If all the values are negative, we will get a 0. However, let's take a look of an example, try to understand it. So let's take a look of this one. In this example, we have several numbers over here. Some of them are positive and some of them are negative. Again, the problem is that we want to find the maximum contiguous subsequence that gives us the highest value of the sum. So let's take a look. If we're starting with the first one and including the next one, then we get a negative 8. Obviously, this is not going to give us a maximum value that we are looking for. So let's take a look at this. If we're starting to sum up all the values, we get a negative 11. Obviously, this is pretty small and it's not the maximum value. So the same sequence, if we're starting with 1 and with 3, then we found out the sum is 4. 4 is greater than negative 11. Again, all of the values need to be in a contiguous fashion. So they need to be connected with each other. So we find a starting point and we try to keep going until a certain point, and we try to find the sum of that. And the problem is try to find the maximum that can provide us in the given sequence. So let's take a look of another example, starting with 1, and again they need to be contiguous. So we look until 7. This time we get a value of 4. So we have a longer sequence, but we didn't get a better value. Still 4 compared with 4, and that's the sum we can get from this starting point to this end point. So if we go further, starting with this location, go until the end of that location, we actually get a little bit higher. We get 6, which is higher than 4. And this is the problem we want to look at. So saying that and we can start at any location, end in any location, as long as they are contiguous. So saying that we started with the value of 2 and end of 7, in this case, we get a value of sum of 9. So this is actually the current maximum that we can find. Is there any other places that can give us a higher value? That's what we need to keep looking. And once we find all kinds of combinations, we will be able to find the maximum value. So you can see that if we go from 2 until the location of 3, we actually get 11. And that is actually a very high value compared with all other values that we are looking for. And we need to keep looking to see if that is really the best solutions. So if we continue from 2 to end with the other 2, we get the maximum, we get a sum equal to 4. And among all of these tests, we actually realize this is the sequence that gives us the maximum continuous. The sum is 11. The starting point is at the location of this 2 index until this 3 index. And that is the problems that we want to solve. Like I said, this is not a very easy problem, like as simple as binary search or search problem. So you need to understand the problem first, and then we will dig into how do we solve the problem. In order to make sure you understand it, take a look of this sequence. Try to pause the video, try to find the maximum contiguous subsequence, and then also identify the initial index and the end index to give the complete answer. So please pause it, and then once you find the maximum, and we can continue. Assuming you already find it, that the maximum sum that you can find in this example is starting from index of 1 goes to the end of index 4, and the maximum sum is 10. So that is what we will be able to see in this example. Let's try another example. So the only thing I change is the last value, and then pause the video, try to find out what is the maximum contiguous subsequence and what is the starting index and what is the end index. Here is the answer. The maximum contiguous subsequence is 11 and from index of 7 to 9. So these are the two examples I want you guys to practice on your own. Make sure you understand the problem completely so that we can continue our discussion. Of course, here is the extreme example with all the values are negatives. Of course, in this case, we would, by the definition of the problem, the maximum contiguous subsequence equals to 0. Of course, our program basically need to handle this kind of spatial scenario so that we can provide complete answers. By looking into the problem definition one more time, we try to find the maximum contiguous value from a sequence of numbers. And these numbers, some of them are positive, some of them are negative. We also need to identify the index of the starting index to the end of the index. And maximum continuous subsequence sum is 0 if all the integers are negative. So this is the problem definition. And what you may curious, what is this problem good for? So here is an example I found on the internet, and I think this is a very nice example, a daily life example that you can get understand of. So saying that you are a club owner, okay, you own a club, and of course, you know, inside the club is usually dark and loud. It's hard to count how many customers that you have in the club. And since you are the owner, you want to maximize the revenue. So you want to know how many people are there in your club. So this is one interesting example. As you know, the club usually have like one entrance with a revolving door. So we will be able to keep track of how many people goes in and how many people goes out. So we can set up a window of the time, say 10 minutes. We can keep track of how many people comes in, how many people goes out. If in the case of the 10 minutes, we have actually one more people goes in, so we get a positive value. And in the next time, saying that we have another period of time, the net people is 3 people comes out, and then we will be able to find a negative values over there. So if we are able to find the maximum contiguous subsequence in this data, then we would know during what time we have the largest amount of customers in the club. So this is the idea of what we can really use this problem in our daily life to solve a real problem. So, programming time. How do we tell computer to solve the problem? As you know, this is not a very easy question. For human, we need to actually test a lot of different combinations and then try to find the answer. So for computer, we would start with what we call the brute force way, which is like dumbest way to solve the problem. And basically, the dumbest way is try all combinations. Just like when we were trying to find the closest 2 points on a 2-dimensional space, we calculate a distance matrix. That's all combinations, and we find the minimum one. Similar things over here. We try all combinations and then we try to find the maximum one. So how do we do that? How do we write a kind of stupid program, but it will work. It's a brute force approach to do so. So what we are going to do is that starting with understanding how many elements that we have. So we use the similar things, n equal to a size, finding out how many elements that we have. And then we initiate the maximum sum equals to 0. So that gives us a variable to hold the current maximum sum that we found. And of course, every time we find a bigger one, we update our maximum sum. In this program, we will start using a first for loop indicating that where do we start looking, and then we will have another for loop to look into where do we end the search point, so that we can depict the starting point and the end point. Among all of those points, we try to calculate the sum between index of I and index of j, so that we use another k loop. You can see that we start k equal to I, k less or equal to j. So the k loop will literally go through all the locations that I pointed until j pointed. And inside of that loop, we simply sums up all the elements that we walk through and then find the sum of that. If we find this sum is greater than maximum sum, then we update it with saying that the maximum sum equal to the sum that we generated, and we also want to keep track of where does it start and where does it end. So let's take a look at an example and then try to understand it. Saying that starting with n equals to 10 elements, these are the 10 elements that we have, and we initiated maximum sum equal to 0. Starting with I equal to 0, j equal to I equal to 0, and then this sum is initiate equal to 0. So when we try to do the k loop, we were starting from this location, I location goes to the j location, and we sums up all the values that we have found between this range, and we will get this sum equals to -2. Since this sum is equal to -2, it is not greater than maximum sum, so we will not update it. And then we will move our j to the next location. And basically, I do prepare several slides as well as the videos to go through this example. Before I close this video, let me go back to the program and make sure you understand what's happening in this program again. So again, we're starting to identify how many elements that we have. We initiate the maximum sum equal to 0. We use a I loop to indicating where do we start to look. J will starting with the location of I and then go through each location until the end of it, so that it will generate all possibilities from I as a location goes to all possible end location as a j, and then inside of that we will use a k loop to walk through every single one of that, and then sums all the values that we walk through using the k loop over here. If this sum is greater than maximum sum, we need that information, so we will store that information. A little bit details I want to look into this program is that the first for loop is basically need to go through n elements. The second loop, j, starting with the location of I and then goes to the end of it. So basically it still goes through n elements. It was starting for where I started, so when I goes toward the end, j will have much less spaces to walk through. However, in the beginning, you still need to walk through all the elements, so averagely speaking, it's probably half of n. The k loop is going to go through where I started and j ended. So literally, if we use the big O notation concept, we understand it still go through n elements. One thing you need to notice is that they are nested to each other. So I can tell you at this moment, and we will look a little bit deeper in that, If they are nested to each other, n multiply n will give you an n cube operation.